Welcome back, guys. In this episode, I'm going to prove that the VCG mechanism that we calculated in earlier episode is in fact strategy proof, which means no player, buyer or seller, has incentive to lie. Or put differently, both the buyer and seller has incentive to tell the truth. Okay? So what does that mean? If you go back and check the definition, formal definition of strategy-proofness, it basically means the following. Well, the buyer and the seller should prefer telling the truth over lying. Well, for buyer, let's first focus on the buyer, okay? And then I'm going to do exactly the same thing for the seller. So the buyer, this is his true type. Okay, and he declares his true type. This is the seller's declaration, and this is the buyer's true type. I mean, you'll see why I'm writing this twice. So this should be greater than or equal to the buyer's, this time declares his type as theta b hat. The seller still declares the same thing, theta s hat, but the buyer's true type is theta b. All right. So given that the buyer's true type is theta b, telling the truth versus lying. This is the comparison we're making, and telling the truth should benefit the buyer more than the seller. Weakly, all right? Doesn't have to be strictly. And so this has to be true for every theta b hat, and theta s hat. All right? Well, the buyer's utility does not depend on the seller's true type because the buyer doesn't know the seller's true type and the mechanism designer doesn't know the true type of the seller. So therefore, it only depends on the declared. So these are declared types always, okay? Declared. Good. So how am I going to make this, how am I going to show this? Well, and I have to show that this is true for every theta b hat, theta s, which I know there are infinitely many of those. Okay, well, the thing is, the decision rule, the transfer function, they all depend on whether theta b, the true theta b, is greater than or equal to or less than theta s. All right. Well, here I'm sorry. I said true. So declared. So the D, the TB, TS. These are all what the mechanism designer determines, and the mechanism designer doesn't know the true types. The only thing he observes is the declared type. So therefore, the D depends on DB hat, the theta S hat. Okay, same for TB and TS. So therefore, I have to make a case analysis. There are two cases. I'm going to call the first one case A, where the buyer's true value is greater than the seller's declared value. And then the second case, I don't know if this place is going to be enough for this, but let's see. The second case is going to be theta b is less than theta s hat. Well, the theta b is telling the truth, all right? So now I'm going to bring, what about the buyer's lie? So when he lies, so here I know that in this case, when the buyer tells the truth, the D is going to be equal to 1. So therefore, utility of the buyer, all right, is going to be 1. What? Well, D is equal to 1 in this case. So this is 1. His true type is theta B plus TB. So TB is going to be this term. It's minus theta S hat. Okay? Well, why do I put hat here? Well, because again, the TB, D, TS, they all are functions of the declared types. And so whenever you see hat, it means declared. Well, this theta B is also declared, but declared true type. All right? I hope that wasn't too confusing. Well, what do I know? Well, because in this case, I assume that the theta b is greater than theta s hat, well, this is a positive number. So the question is, by lying, all right, by lying, meaning whenever you declare some theta b hat different than theta b, all right, so you can think of this theta b hat equals to theta b. So when I declare something different than this, can I still get a number greater than this? Okay, that's the question. Or am I going to get something always less than this, which is what we should show. Well, okay, so theta b hat is not going to be equal to theta b. Well, there are many possibilities or cases, right? So I'm going to call it subcase 1, which basically is the following case. Theta b hat greater than theta b and greater than theta s hat, right? Or subcase 2. Well, you know what? Theta b can be greater than theta b hat, which is greater than theta s hat. I don't look at the equality case because this is the equality case. And then subcase 3, theta b greater than theta s hat, greater than or equal to theta b hat. All right? So the buyer lies and he exaggerates his valuation. I mean, if you got the intuition, if you're the buyer, you don't want to exaggerate, you know, oh, I love this good. You should say something like, you know what, I don't really care whether I get this object or not. So if you're the buyer, you try to not exaggerate your valuation, but sort of decrease the valuation that you declare. So here, the buyer exaggerates his valuation. Here decreases, but not as much as the seller. So there's still trade. And here it says, well, almost like, I mean, I don't really care how much your cost is. I don't really value that much. All right. So that's it. The theta b hat can take one of those 3 values. So all I have to do to finish case A to analyze those 3 subcases. Let's do that. So if you look at the subcase 1, all right, what happens? This is the number I should be focusing versus this. The theta b hat still greater than theta s hat. So the buyer's declared valuation is greater than theta s hat. By the way, if you like, you can put hats all here because remember I said these all are declared types when it comes to D, TB, and TS. So in the subcase, the trade should still occur, all right? Meaning D is still 1. But what is the utility? Let's call it UB theta B hat, theta S hat. Well, it's going to be, well, this guy, D, which is still 1, times the buyer's valuation. Should I multiply it by theta B hat? No, be careful. At the very beginning, I wrote the utility function, which is exactly why I did it. The buyer's utility, his declaration is not his true valuation. So he's not going to multiply. We're not going to multiply D but with theta B hat. We have to be multiplying it with by theta B because this is his real, original, true valuation. What else? Plus TB. And TB in this case is minus theta S hat, which is exactly the same as this. So therefore, declared utility is this, lying is this, so therefore no profitable deviation because lying and telling the truth will give you the same utility in this case. Well, what about subcase 2? Well, still the declared value for the buyer is higher than the seller, so D is 1. And again, the utility of the buyer in this case is still the same. Theta B, because D is equal to 1, minus theta S hat, which is still the same as telling the truth, and so no profitable deviation. Well, finally, in subcase 3, the buyer's declared announcement is less than the seller's or equal. Well, in this case, the D is equal to 0. So therefore, the buyer's utility of lying, theta B hat, is 0 plus TB. Well, what is TB in case of no agreement? 0. So it's just 0. Well, again, remember when he tells the truth, his utility was positive. When he lies, his utility is 0. So no profitable deviation. By lying, you cannot increase, the buyer cannot increase his utility. He's going to get either the same thing or less. This is what we show. Okay, so now let's look at case B. What is case B? Remember the buyer, buyer's true, when the buyer declares his type as his true type, which is less than the seller's declared type. In which case D is going to be equal to 0. So U of B, when theta hat equals to theta B, comma theta S. Well, you know what? I'm going to ignore this comma theta S hat business because it's just taking a notation with no purpose. So what is that equal to? It's equal to D times theta B, where D is 0. So it's 0 plus TB, which is 0 again. So it's going to be 0. Question, so this part is 0. By lying, can I get a positive payoff? Well, once again, there are 3 cases. Subcase 1, where theta B hat strictly less than theta B, which is less than theta S hat, right? Subcase 2, theta B is strictly less than theta B hat, strictly less than theta S hat. And then subcase 3. Theta B less than theta S hat, less than or equal to theta B hat. All right? So, if you look at subcase 1 and subcase 2, I'm going to analyze both of those cases. Why? Because the declared types are such that the trade shouldn't occur, meaning D is equal to 0. So, in this case, the buyer's utility, when he lies, theta B hat, is just 0, because again D is 0, and when D is 0, transfer is 0 as well. The interesting case is subcase 3, because in this case the buyer declares that he in fact values more than the seller. So in this case D should be 1. The mechanism designer is going to say, well then D is 1. So in which case the buyer's utility is going to be what? D is 1. But it should be multiplied by true type, theta B, plus the transfer. It's minus theta S hat. Okay, what do I know? Well, remember theta B is strictly less than theta S hat. So therefore this guy is negative. So, by lying, the buyer is either going to get exactly the same utility, 0, or less than 0. So therefore, the buyer has no profitable deviation. Meaning by lying, the buyer is not going to be able to get higher utility. Hence, I'm done with case A and case B. My conclusion is that the buyer has no incentive to deviate. All right? But remember, strategy-proofness says no player has incentive to deviate. So that means I have to do exactly the same analysis for the seller, which is what I'm going to do next. All right, so now I am looking at the seller's case. And I wrote things in advance because I basically do the same thing from the seller's perspective, but the logic is going to be exactly the same, so I don't want to spend too much time on writing. So what we should be checking is this: the utility of the seller when he tells the truth should be greater than or equal to utility of the seller when he lies. All right, so theta S hat is different than theta S, means he lies. And this should be true for any theta S hat, and theta B hat. Okay? Well, again, there are 2 cases. Case A is when the seller declares his true type, which is less than the buyer's true type, in which case D has to be 1. And the second case, which I fill later, is the seller declares his true type, which is greater than or equal to the buyer's type, in which case D should be equal to 0. So when D is equal to 1, well then telling the truth is going to bring utility 1 times theta s, right, the seller's true type, plus the transfer. Remember, the transfer of the seller is 0 when the buyer's declared type is greater than the seller's declared type. So therefore, the seller's utility of telling the truth is minus theta s. Okay. Question is, can seller make more than that by lying? There are 3 subcases. He lies, but he declares his type to be less than his cost. He declares his cost lower than the original cost, higher than the original cost, but lower than the buyer's type. And finally, he declares his type, the cost, as being higher than the buyer's type. Well, if you look at the subcase 1 and 2, what happens is that the buyer's declared type and the seller's declared type are going to satisfy this. The buyer says, I value your item more than your cost. So according to the the mechanism designer, trade should occur, meaning D must be 1, in which case, once again, the utility of the seller, this is the utility function we are focusing now, is going to be minus theta s, which is exactly the same as telling the truth. So lying is not going to benefit the seller in those 2 instances. What about the subcase 3? Meaning if the seller says his cost is much higher than the buyer's valuation, well, in this case, D must be deemed to be 0, right? Because the mechanism designer is going to look and say, hey, the cost is much higher than the value and value of the buyer, so there shouldn't be any trade. In which case, if there's no trade, the utility of the seller is 0 plus the transfer. Remember, the transfer is minus theta b. So therefore, theta b hat. So the seller's utility of lying is going to be minus theta b. Question is this less than minus theta s? Yes, because theta b hat is greater than theta s hat. Theta s. Well, if you multiply both, this inequality, minus theta s greater than minus theta b hat. So therefore, the utility of telling truth is always higher or equal to the utility of lying. So therefore, there's no profitable deviation for the seller in this case. Okay, let's move on to the second case. Okay, so in the second case, we know that we argued that D should be 0. So when the seller tells the truth, his utility is going to be D is 0, transfer is equal to minus theta b hat. All right, so his utility is minus theta b hat. Question is, can he make payoff better than this by lying? Well, again, there are 3 subcases. He says that his cost is higher than his actual cost. He declares that his cost is actually lower than his actual cost, but higher than the buyer's valuation anyway. And then he declares that his cost is actually lower than the buyer's valuation. So in subcase 1 and in subcase 2, the buyer's valuation are lower than the seller's valuation. So therefore, according to the mechanism designer's decision rule, there shouldn't be any trade. So D is equal to 0, which basically means that the seller's utility is just TS, the transfer, which is equal to minus theta b hat, which is exactly the same as the utility of lying. Okay, now let's look at the subcase 3. In the subcase 3, the seller declares his cost being lower than the buyer's valuation. Well, in this case, by the way, the seller doesn't know this. It's just, let's suppose the seller declares and it falls into this category. What's going to happen to the utility of the seller? All right, this is what we are calculating. So according to the mechanism, the trade should occur, so D is 1. Well, what about the utility? Well, the D is 1, so utility of seller is theta S minus theta s, I'm sorry, plus the transfer, and the transfer is 0. So it's minus theta s, hat, I'm sorry. Oh, not hat, this is the true theta. Sorry, I got tired. So the question is this guy, minus theta s, higher than or lower than minus theta b hat? Well, in the previous case, we said it's actually higher. But don't forget, this was true when this is the case. All right? However, here we have the opposite of it. Remember? So theta s is greater than or equal to theta b hat. If you multiply this inequality, minus theta s is less than or equal to minus theta b hat. So therefore, utility of lying is always giving less utility. Utility of lying is always less than or equal to utility of telling truth in case B as well. So therefore, there's no profitable deviation for the seller in this case either. In conclusion, we previously proved that the buyer has no incentive to deviate. Here we proved the seller has no incentive to deviate either, which means no player has incentive to deviate, which means telling the truth is a dominant strategy for all the players, and hence the mechanism, the VCG mechanism in this particular example is strategy proof, as we already knew, we just verified it. But again, this is not a beautiful mechanism in this framework because it fails to satisfy individual rationality and budget balancedness. Okay?